Assalamu alaikum and welcome dear students of mathematics. This is the third part of the first lecture on computational fluid dynamics, and we will solve out two of the examples. First example is we have to find out a finite difference approximation of partial f by partial x, and its order is delta x square. Note that in the first lecture, part A, we had found the mathematical expression for the same formula and its order was delta x, but here we have to find out an expression whose order is delta x square. Next we will find a forward difference approximation of the third order derivative of f, and its order is order delta x. First we will solve out this example because this is very easy. Although first we will use the Taylor series f of x plus delta x, and it was this expression, and the viewer must be well familiar to this Taylor series. Next, by the use of we will mark out this Taylor series by equation number Roman 1. Next, we will use the same Taylor series and we will find out f of x plus 2 times of delta x, and this was done in the part 2 of the first lecture, and it was equal to this. Note that third term is 2 delta x whole square, which is equal to 4 times of delta x square divided by 2 factorial, and next one is 2 delta x whole power cube, and it is equivalent to 8 times of delta x cube divided by 3 factorial, and 3 factorial is replaced by 6, and next term contained the 2 delta x whole power 4, and therefore this next term and all of the upcoming terms are replaced by order of 2 terms of delta x whole power 4. Next, we will find out by using the same procedure the equation of f of x plus 3 times of delta x by using the Taylor series, and this comes to be equal to f of x plus 3 delta x plus this expression plus this term and order of 3 delta x whole power 4, and mark this equation by equation number 3. Now, apply the mathematical operation 3 times of equation 1 minus equation number 3. You will find out this expression. You will have to perform it on your notebook, and the result is 2 times of f of y minus this expression and plus order of delta x raised to the power 4. Next, you will have to apply the operation equation 2 minus 2 times of equation 1, and the result is f of y plus 2 minus 2 times of f of y plus 1 minus f of y plus this expression delta x cube partial cube f y partial x cube plus order delta x 4 power 4, and mark this equation by equation 4 static. Next, apply the operation equation 4 plus 3 times of equation 4 static. You will get the forward difference of formula for partial cube f by partial x cube. You will have to do it by yourself on your notebooks. The explanations are left as the exercise because for the sake of time. Now we move to the example number 1. Okay, the third derivative approximation is f of y plus 3 minus 3 times of f of y plus 1 plus 3 times of f of y plus 1 minus f of y divided by delta x cube plus order of delta x. That was our required formula, and you will have to derive it by yourself. The operations are given here and the explanations are written here, but you will better understand by yourself by performing these operations on your notebook. Next, we have to find out a finite difference approximation for partial f by partial x, first derivative, and its order is delta x square. For this, we will have to go to lecture 1 part A, where we use the Taylor series, and from the Taylor series we found this formula for partial f by partial x. By using this Taylor series, and you have to simply eliminate partial f by partial x, and this was equal to partial f by partial x plus this term and up to so on. We will simply use here the a finite difference formula for partial square f by partial x square. Now partial f by partial x was equal to this one. Now we will replace the forward difference approximation for partial square f by partial x in this, and this was equal to, go to the second lecture, part B lecture 1, where partial square f was equal to this one, and from the previous equation partial square f by partial x square was equal to this mathematical expression plus order of this one. You have to simply replace this equivalent formula into this partial square f by partial x square, and by doing this you find out partial f by partial x to be equal to this term plus delta x by 2, plus this is replaced by its equivalent forward difference formula, which was f of x plus 2 delta x minus 2 times of x plus delta x plus f of x divided by delta x square plus order of delta x. The third term and all of the next terms will remain as themselves, plus up to so on. Next you had to cancel delta x by this delta x square, so that in the denominator we have 2 times of delta x, and this is explained, this is written here. Next, note that the order of delta x square comes because here delta x square appears and delta x square appears in all of the next terms, therefore they are simply replaced by order of delta x square. And also when you will multiply delta x by this one, it would be cancelled by this, but this delta x when multiplied by this makes it order of delta x square, and this order of delta x square and these all of the next terms of order delta x square are combined, and they're simply replaced by order of delta x square. Next, you will have to combine this and this, and by combining this you will get this expression. You will have to do it on your notebooks, and you will have to simplify them to get this expression. Therefore, by using I subscript, we simply get partial f by partial x to be equal to minus f of I plus 2 plus 4 times of f of I plus 1 minus 3 f of I divided by 2 delta x plus order of delta x square. Note that you will have to perform these steps on your own notebook for your familiarity. So thank you very much, and I hope that this lecture has delivered something to you. Thank you very much.